maybe let's do a quick review graph. So you don't even have to write it down, just kind of watch and see if you remember. Because we finished up the graph unit last time. So let's see if we remember how to graph something like y equals -2 cosine 4x. All right, so, gosh, there's all this stuff floating around in my mind. One of the things that's floating around in there is, what does a cosine even look like? Well, we should remember that the cosine is the one that starts up here, right? And remember, they always end in the same spot they started. So if it starts up here, it ends up here. Okay? All right, so tell me now, okay, that's what it looks like. What about this one, though? There's something a little bit different about this one. It's upside down. So instead of starting and ending up, it's going to start and end down. So here's where it starts, here's where it ends. There's its peak, and there's where it crosses, all right? Can you tell me anything about these labels? I need to label those. What will those be? 2, because of that. That is my amplitude number. So it's going to be 2 and -2. Right? Now, normally, these labels would be 90, 180, 270, and 360. Those would be the normals. But I didn't put them up here in the actual graph because I've done something. What have I done? Divided. This is a divider. Divide by 4. So these labels would be 22 and a half, 45, 67 and a half, and 90. Okay, so that's sort of coming back a little bit. Okay. All right. So what are we doing today? Well, total shifting gears. Everything now we're thinking backwards. So let's look at the first problem in 4.7. And it literally says, find the angle whose sine is 1/2. Right? So somewhere out there, there's an angle, and its sine is 1/2. So what would that angle look like? Always draw a picture. Here's my triangle. If the sine is 1/2, then doesn't that have to be 1 and 2? Right? And I need to know what this angle is. Well, do I have enough information there? Or should I go ahead and put the √3 here? It's not really part of the problem, but that might help. What angle is this right here? 30 degrees. So the answer to the question is 30 degrees. Okay, easy. All right, how about B? The angle whose cosine is √3/2. This notation literally says find the angle. So find the angle whose cosine is √3/2. Adjacent over hypotenuse. Is that the same? So the answer to that one is also 30 degrees. Now remember, if you are doing this without a calculator, you are always going to be either 30, 60, or 45, right? Some version of that. So don't be alarmed if you get the same answer more than once. It's to be expected. All right, next one. Find the angle whose tangent is root 3, and I'm going to make that a fraction because tangent is a fraction, opposite over adjacent. So find the angle whose tangent is root 3. So what does that look like? Opposite, adjacent. What angle is that? 60. So the answer to the problem is 60 degrees. Beautiful. And now the next one, a little bit. We have to have another piece of information. What is a little different about the next one? It's a negative. So I just erased one. Here are the other two. I've been drawing in quadrant 1. Right? Not going to draw this one in quadrant 1 because there is nothing negative in quadrant 1. So this is the new part that you have to remember. As long as your number is positive, draw your angle in quadrant 1. So as long as that number is positive, you're going to draw this picture. Okay, labeled differently or whatever, but that is your picture. If your number is negative, if it is a sine or a tangent of a negative number, so a sine or a tangent, you're going to draw it in quadrant 4. All right? This is 4, did not make up the rules. This is what the rules are. Somebody made up the rules a long, long time ago. If it's a cosine and it's a negative number, it's in quadrant 2. That is info that is built into your calculator. He knows that. It's on his chip. You need to get it on your chip. All right? It's not on the orange sheet. You need to know it. Okay? You need to know it. Okay? All right, here we go. This is a sine. My rules state it needs to be drawn in quadrant 4, so there it is. Here's the angle I'm looking for. Opposite and hypotenuse look like that. Opposite over hypotenuse, that sine. Everybody good with that? Now, can you tell how big that angle is? Yeah, this is a 1, 1, root 2 triangle. But don't say 45, because didn't we come down to get that angle? So negative 45. So the answer is negative 45 degrees. We came down to get it. We didn't go up like we did here. We came down. Okay? All right, cosine. Find the angle whose cosine is negative 1/2. Okay, so the first thing, that's negative. So we gotta make sure we get it in the right quadrant. For cosine, the right quadrant is 2. So we're gonna draw quadrant 2. There it is. There's a picture of my angle. Now what do I know about it? It's cosine adjacent over hypotenuse is 1/2. By the way, will I ever put that negative sign on the 2? No. Hypotenuse is never negative. So I got a 1 and a 2. What's this one? Not 1. It's not a root 2. It's a 2. So this has to be a root 3. You gotta pay attention. What angle is here? 60. But wait, you're right, you're exactly right. But 60 isn't the answer, because if 60 were the answer, we would be in quadrant 1, between 0 and 90. That's where 60 is. I need this angle right here. I need the angle that's in quadrant 2 that makes a 60. Remember, you always start here. So I gotta get around to quadrant 2 and make a 60. So how big is that green angle? I heard somebody say 120 and you are my hero. That's exactly what it is. It's 120 degrees. How do we know it's 120 degrees? Because all the way to here is 180, right? I came this far, but there's still 60 to go. So 120 and 60 would give me my 180. So the answer to the problem is 120 degrees. That's tricky. You gotta get around into quadrant 2. All right. Next one, tangent -1. Which quadrant am I drawing this in? 4? When in doubt, look at my cheat sheet up here. Tangent negative quadrant 4. And I know the tangent is 1/1. I always make that a fraction. So negative 1/1. How big's my angle? 45. But since I came down to make that 45, negative 45. If you told me it was positive 45, that would be up here, right? So it can't be up there, it has to be down here, negative 45. Solver? Never, not with this notation. No inverse functions exist in quadrant 3. So all the positives are in 1. Negative sine and tan are here, and cosine's here, that's it. All right, what am I ready for? G? All right, so see if you can do this one by yourself. Notice it is a positive number. So you are going to draw that in quadrant 1. All right, so go ahead and see if you can give me the answer for the angle whose sine is √3 over 2. Julia, you sitting there, you got it? What'd you come up with?
I got 60.
She got 60. What do the rest of you think? Is Julia right?
Yeah.
She sure is. 60 degrees. Quadrant 1. All right, now you think you're so smart. Let's try H. Now that one is an inverse cosine negative √3 over 2. So the first thing you want to do is make sure you get it drawn in the right place. Vanessa, where are you drawing it? Second quadrant, yep, right here. Remember, your final answer is going to be this angle. That's going to be your final answer. You're going to find this one right here, but that isn't going to be your answer. Anybody have an answer to share? Well, I heard a 150, and that's exactly right. Why is it 150? Well, negative √3 over 2 is your cosine. That means your reference angle here is 30. You need that reference angle. So draw the triangle and find this angle. Then we'll subtract it from 180 to get 150. You feel okay? Right now, let's throw a little wrench in here. And once you to think about, this is 0 over 1. Do any of your triangles have a side of 0? Guess what? We're not going to draw a triangle this time then. We're going to use a circle. And we're going to go around the circle with a radius of 1. There are all of our points. And we're going to find the one where if we put y over x, we get 0. Remember, tangent is y over x. So where does that happen? Let's start right here at 0. This is the beginning. Right? Oh my. Is that it? Y over x? 0 over 1? So what angle is that right here? What angle is this? 0. So the answer is 0 degrees. How did I know I needed a circle? Because there is no triangle that has opposite 0. Right? I see some of you looking at the clock. The period will be over. Try to stay focused. Now this one can be a little tricky because you see that 1 over 1 and you immediately think about your 45, 45, 90 triangle. But be careful. This one is the opposite. And what's this one? Hypotenuse. Is there a triangle that has a hypotenuse of 1? No. So guess what? We're back at the circle. And it's that same circle. When you're on the circle, this isn't going to change. But this time, I want y over r sine to be 1 over 1. Alright? So r is 1. That part's good. Where is the sine also, excuse me, where is y also 1? Look at your y coordinates. Is y 1 here? Is y 1 here?
Yeah.
Wouldn't that be 1 over 1? Y over r? What angle is that? 90 degrees. So this is 90 degrees. Because right here, x is 0, y is 1. So when you put y over r, you get 1 over 1. Okay? All right, let's look at the next page. Oh my lordy. These look scary to me, and I'm curious. All right, so I want you just to take a deep breath. This is actually easier than the ones we just did, but you have to do things in the right order. So you know, because of PEMDAS, that we always start inside the parentheses. So I'm going to cover that up so that it doesn't bother me. That's a positive number, so I'm going to draw my triangle in quadrant 1. Positive number, always quadrant 1, no matter what. Opposite over adjacent, this is a tangent value. Opposite over adjacent is 3 over 4. We've seen stuff like that before, and what did you do? At this point, you did the Pythagorean theorem. So let's do that. Go ahead and do your Pythagorean theorem. And tell me what you get for your hypotenuse. What? You don't get 25, you actually get the square root of 25, which is 5. 4 squared plus 3 squared is x squared. 16 plus 9, 25 is x squared, so x equals 5. Okay, so I have looked at my parentheses and I have drawn my picture from the parentheses, okay? Now, looking at that triangle, what's the sign? What's the sign in that picture right there? What sign? Opposite over hypotenuse. So the answer is 3/5. Draw a picture of your parentheses. And then once you got everything labeled, find whatever that is, the sign in this case. All right, let's try the next one. Find the cosine of the angle whose sine is 5/13. All right, so what do I do first? Cover that up and draw a picture. Which quadrant will it be in? 1. How do I know it's in quadrant 1? Because that is a positive number. So here I am in quadrant 1. The sine is 5/13. All right, now you do the Pythagorean theorem this time, and let's all get it right. Do the Pythagorean theorem to find your missing side. What? Vanessa says 12, I think she's right. 169 minus 25 is 144, the square root of 144 is 12. Beautiful, beautiful, beautiful. X squared plus 5 squared is 13 squared. That's your setup. Perfect. As soon as you are done, then answer the question. What do I want to know? Cosine. What's cosine? Adjacent over hypotenuse. So the answer is 12/13. One more, and then I'll stop. Okay, so always start inside. Draw your picture. Now be careful. Do you notice that's a negative number? This is a sign, and that's negative, so I'm going to draw it in quadrant 4. That's my rule. I memorized that. Opposite over hypotenuse is 4/5. So then I do my Pythagorean theorem, and it looks like x is going to be 3. And then I answer the question. I want to know the tangent. So what's the tangent? Remember, your angle is always at the origin. What's the tangent of that picture? -4. Very good. All right, we'll finish this up tomorrow. Don't forget your cereal, office hours on Wednesday or Friday.